If you remember from the previous video, this is a problem related to water quality of a stream. A group collects a liter of water. So we're taking samples of water at 45 different locations along the stream. And the measurement here is the amount of dissolved oxygen. So it's given in milligrams per liter. I think the per liter is missing here. So this is mg per liter. So since we are collecting it from 45 samples, n, the sample size is 45. When the sentence says the mean is 4.62 milligrams per liter, it's basically referring to the sample of water collected at 45 random locations. So therefore it is the sample mean. Now once we figure out what each of these letters are, sigma is the population standard deviation. That's an important thing to know. Is sigma given or not? That's a very important question we need to answer before we jump into solving it. Now, the most important thing is to read the question. The question says, is this strong evidence that the stream has a mean oxygen content of less than 5 mg per liter? So clearly, this is not a question where we are asked to calculate the population mean dissolved oxygen. The question here is asking us to prove something, to find evidence for something. So is this strong evidence that the stream has a mean oxygen content of less than 5 mg per liter? So clearly this is a hypothesis test. When you're trying to prove something about the mean in chapter 14, then that is a hypothesis test. If you're trying to estimate the mean, then that's a confidence interval that you need to construct. So how does the 4-step process work? The first step is about writing a clear and concise statement about what the question is asking us to do. The question says, is there evidence that the stream has a mean oxygen content of less than 5 milligrams per liter? So basically, that's the question we're trying to answer. So this is how we're going to write down the sentence. Always, if it's a hypothesis test, start off with, we will find evidence. Because that's what we do in a hypothesis test. We try to find evidence against the null hypothesis. So we'll find evidence that the stream has a mean oxygen content of less than 5 mg per liter. That's exactly what the question is asking us to do. The second step is formulate. In the formulate part, we need to think about which process we are going to use in order to solve this problem. And the most important thing that we need to check and be careful about when we're reading a question is sigma given or not? And remember what sigma is. Sigma is the population standard deviation. Remember, all this has to be memorized. It's the population standard deviation, and clearly that is given to us. It says, suppose we know that the normal, that the dissolved oxygen varies among locations according to a normal distribution with with standard deviation 0.92. So 0.92, since it's referring to the group in general, is the population standard deviation. So since sigma is given, that's the most important thing. Since sigma is given, we use the Z procedures. That should be your first sentence. If sigma is not given, in chapter 17, we are going to use the T procedures. We are finding evidence against what is believed to be true. So we do a hypothesis test using the formula for the Z statistic and write down the formula. The formulate should always end with a formula. Now, the minute you write down the formula, it makes us think about what do we have or is there something we can figure out? So let's look at X bar. Is that given to us? Mu O, that should come from the null and alternative hypothesis. Sigma is the standard deviation of the population. N is the sample size. So when you go to the solve part, if it's a hypothesis test, the first thing you have to write down, without which whatever you do is absolutely pointless. Because if you don't know what you're proving, then really whatever calculations you do is meaningless. So write down your null and alternative hypothesis as we've done here. And then do the calculations. Remember, the first step of doing the calculations is to find the z statistic. Take the x bar and convert it to its z value in the sampling distribution. So the sampling distribution has center mu naught because that's what we assume is the mean. So for the sake of argument, we say let the mean be equal to 5 mg per liter. And based on that, we have mu O, which is 5 mg per liter. When you do the calculations, you get a z value of negative 2.77 using table B. We find the area to the left because we talk about mu less than 5 mg per liter, which gives us a p-value of 0.0028, which is way less than our significance level, which is 0.05. So we reject the null hypothesis, and we can also say we have strong evidence to prove our point, which is that the stream has a mean oxygen content of less than 5 mg per liter. Now, finally, we have to make a conclusion. And this is where the statement has to be written very carefully. So the conclude part. Remember, we said we will find evidence. So now you're going to say, we have strong evidence. I say strong because the p-value is very, very small. We have strong evidence. And then in parentheses, we say p-value. This is our evidence, so we need to present it. 0.0028. P-value equals 0.0028. We have strong evidence to prove that the mean oxygen content of water in the stream, since the p-value is small, we have proved that the mean, remember to use the word mean, oxygen content of water, which is mu. Remember to write down mu. When I say mean, it is mu. In the stream is less than 5 mg per liter. So here, the key evidence is the p-value. The p-value helps us make a conclusion based on a 5%, based on alpha equals 5%. So this result was significant. That's how we say it.